Hello, everyone, and thank you for joining us for today's webinar from ATA Engineering, What's New in Femap 2020.2. My name is Jonathan Hill. Normally, I'm joining you from ATA's Northern Virginia office right outside Washington, D.C., and I'm really excited to have Andy Haynes on the line with us today from Siemens Digital Industry Software for our feature presentation. Before we get that far, I'd like to give just a really brief intro to ATA for those of you who might not be familiar with us. ATA provides high-value engineering services with expertise in design, analysis, and test. We get really excited every day to help our customers overcome their most difficult design challenges across a wide range of industries, just some of which are shown here. We're also able to leverage that experience and expertise through our role as a Siemens partner and value-added reseller. In that capacity, we offer training, free resources, and hotline support for a variety of products, which include Simcenter Femap, which we'll be discussing in greater detail today, but some other great tools as well, like Star CCM Plus, Nastran, and NX. Our engineers who are working on those services projects every day actually staff our technical support hotline, which is available from the beginning of the day on the East Coast until the end of the day on the West Coast. And then we're also the developer and the preferred North American provider of SimCenter Nastran training. My final invitation is going to be after our webinar today to check out our software website, where we have a ton of great content. That includes product information and our schedule of upcoming training classes and other webinars. And definitely my favorite part, which is the free resources. And I know I bring this up every time we have a webinar, but we have a lot of great content up there. And the best part is that it's all developed by our engineers, specifically based on what we're hearing from the users we're in contact with. So kind of my final plug here would be that if you have ideas for a future webinar or a resource that you'd like us to think about and put something together for, definitely reach out to me and the rest of the ATA team, and we'd love to make that happen. With that though, I'm excited to turn things over to Andy for today's presentation.
All right, thanks, Jonathan. Let me just share my screen here. All right, I'm sharing. So, hey, everybody, welcome. Today, what we're going to talk about, of course, is what's new in Simcenter Femap 2020.2. There we go. Just a little bit about the Femap direction. I'm not really going to spend a lot of time on this particular slide. I just wanted to mention that we've had 35 plus years of dedicated development for the FEA analyst. So that's you know, that's been the Femap direction, and that will continue to be so moving forward. Just so everybody knows, since the release of version 12, we moved to a 6-month release cycle. So essentially what you're going to be seeing from us now is you're going to be seeing a full feature release every 6 months. It says April, October. Think of it more as fall and spring. That's typically when these releases are going to come out. So you're going to get a feature release, and then you're going to get a maintenance release. It says if required. There will almost always will be at least one maintenance release, which we're going to call MP1. And it really is going to be bug fixes and critical updates only. Hopefully we got enough right the first time that we don't need a second release, but every once in a while, like a new geometry translator might come around or something of that nature that we might just want to put out for everybody as well, and maybe fix some other smaller issues along the way. Anyways, so this has been our roadmap. So it starts with SimCenter Femap version 12 in October 2018, and we get to, you know, 20. We changed our numbering scheme, so we go to right from version 12 to 2019.1, and that was released last June. Then 2020.1 was released last November, and now 2020.2 is actually released in May, but we have actually then even since released 2020.2 MP1. So if you're waiting for the maintenance pack to come out of 2020.2, it's available. Go and get it and start using it. Okay, so one of the big focuses for 2020.2 was performance improvements. So you're going to find that we did quite a bit in this realm for this release. So if you're using Connect Automatic, we made it 3 to 5 times faster when you were making a large number of connections. If you were using the geometry copy or mesh copy commands or even the move commands, These are based on the file merge technology that we have in Femap. And essentially every time you did this, we were doing a full regeneration of the graphics and just a lot of stuff that probably just we didn't need to do in a lot of cases. So anyways, we changed a lot of things behind the scenes, very little that, the only thing that you should notice as a user is that it has a potential to be about 40 times faster. Just change the way that we did length-based sizing on curves for mesh sizing. And while we did this, it also changed the accuracy and speed of using some of our methods, such as a long curve, length along, and midpoint. And so now mesh sizing, when you're doing length-based sizing, is two to three times faster on a large model. There are some commands that can be aborted in Femap. A lot of them are listing commands or commands that do computations of some sort. So just what we found out was we were just checking every time it did a loop for a computation or a list or anything like that. We were always checking for an abort. Well, now we just check for an abort a lot less, and in certain cases we got about 2 times to 100 times speed improvement just because we're checking for the abort less. But as a user, you probably won't even really notice it. You'll only notice the speed improvement. Output process, we know a lot of people make envelopes, linear combinations, RSS combinations. We were able to make that about 30% faster for each one of those. So I know a lot of folks use those all the time. Nastran model read was already kind of very fast in Femap, but we were actually able to do almost a 2 times improvement when you were importing large input files. And also, when we were reading ANSYS results, the RST files, we were able to get a 2 to 3 times speed improvement out of that as well. This is one that probably a lot of you might have encountered and kind of wondered, hey, is there anything that could be done? Well, we really tried to address this. And this was basically, if you were creating an element in an already large model, it was essentially doing a full graphics regeneration every time. We found out we didn't really need to be doing that. So what's the, how big of a difference does it make by doing this? So when you were creating a single entity, in this case, a rigid element in this model, which is 3.3 million 10 noded TETs, it took 29 seconds in 2020.1, but now it takes, 0.3 seconds. So almost a 95 times performance improvement. So you should be able to just, you should notice this right away, especially if using large models when you're using performance graphics, which I hope everybody is using at this point. Yeah, okay, I'll just kind of move on from that. Just a couple of other things in here. For preferences, we added the Control G group evaluate. So basically every time, when you have this option on, every time you do a group evaluate, it'll also perform a view, a window regenerate, or the Control G shortcut key. So this helps when creating entities into displayed groups. And we also added an option to just be able to disable the abort of commands completely throughout the product. I shouldn't say throughout the product, things that abort the graphics draw. That's what this one does. So, and then we also, for whatever reason, when we turned on best possible, we used to turn off max VBO megabytes and min VBO bytes, but those are actually settings that you can set because there are times when VBOs, vertex buffer objects, are still used when you're using performance graphics. So we basically just allow you to choose those, set those values when you have best possible turned on now. Okay, a little bit about UI and visualization. So hopefully everybody noticed in 2020.1 that all the icons changed for Femap. So we redrew every single one of them. They were done specifically to provide a little bit more contrast and be a little bit more consistent throughout Femap. And they were just supposed to, if you're using an icon that does a particular, a particular command for one type of entity, we wanted to kind of look the same for a different type of entity. So we tried to make that, a little bit more consistent. Now, what did we do in 2020.2? Was we basically drew all of them again at 150% and 200%. So now we actually have 3 different sizes for the icons. Now, why is this important? Because once you have this, it allows us to do full DPI scaling, so full user interface scaling. And where you'll notice this most is on a high resolution display, like a 4K display. So if you didn't, when we did not have the full native scaling, we had 2 choices. We could either disable the scaling, which could leave the text and icons small and hard to read, or we could have it handled by Windows. But when you only have one size icon, what that typically leads to is blurry text and icons. So here's just an example. So the left is now Femap fully high DPI aware. The middle was native scaling, and then no scaling was on the right. And I think we can all agree that the one on the left is probably going to be the easiest one to use. Something we added for 2020.2 was curve connectivity. So this is what this is we actually create an override color based on the surface connectivity. So we essentially have 3 different ways that surfaces are connected. So either they're not connected, so they're free, they're manifold, so they're stitched together, or they're not non-manifold, so there's more than 2 surfaces are attached, or one surface is coming into another surface at a T-junction. So what we did was we allowed you to basically come in here, turn on the draw option, and then you can pick your colors for free, manifold, or non-manifold. Wire body is also something that, wire bodies are also a parasolid entity that we can read in. So we actually decided to give them their own color as well, you know, just in case you wanted to kind of see that what was a Femap curve as opposed to what was a wire body. Okay, so anyways, you now have this option, and we can turn it on via the view style menu on the view simple toolbar. So I'm just going to go to Femap for a second, and I'm just going to show you how this kind of changes. So I'm just going to turn on my curve connectivity. And you can see in a lot of cases in this model, after I've mid-surfaced and I've made some modifications, a lot of these are free. A lot of these curves are free. But if I then go to geometry surface non-manifold add, and I just pick these, say OK, you can see that now I have a lot of the curves. So everywhere there's now a T-junction or a non-manifold junction, they've become yellow. And also just through the non-manifold add process, some of these edges are now manifold edges as well. So those have become green. And it's just a nice way to be able to see that your geometry is connected. Okay, just going to go back here to the presentation. We had a bunch of renumbering options. Anybody who's used the modify renumber all command, notice that we had options to compress offset to and offset by. We just basically now added those same options into all of our renumbering commands just because they make more sense. They're a little bit more straightforward. And you typically then know, based on which one you have chosen, exactly what values you need to enter at the top. Something else we did was we added the ability to send formatted HTML to the clipboard, or be able to save it to a file whenever you're using copy to clipboard or save to file commands. So what this is going to do is it just improves formatting when you're pasting into the Office tools, and also allows you, if you want to open with a standard browser instead of instead of a something like Microsoft Word. The next thing that we did, and this is pretty interesting, is we actually have new technology that just allows Femap to talk directly to Excel. So basically what you're going to see is you're going to see a lot of these send to Excel buttons, commands or icons in either in dialog boxes or in panes. So here you can see there's one in the layup editor. There's one in the standard entity selection dialog box. We also added panes So say the data table, the function table editor. So when you click these, what happens is Femap automatically opens up Excel and then sends this directly over with all the formatting. Another place you're going to find it is here in the charting. And when you do the charting, it sends the XY data pairs for all the data currently charted, displayed in the charting pane, along with a picture from the charting pane. I'm just going to go over into Femap for just a second again. Just kind of wanted to show you this. Let's just say we had a free body listing here. Again, I can just do send to Excel. And what that's going to do is it's just going to automatically open Excel for me and then send this over in a formatted style. So let me just click off here so you can see it. All right. Let's go back to the presentation. Another thing we did was we added the center option to include in dynamic rotation, which displays this little symbol. So when you have this turned on in the preferences, as you rotate the model, it's going to show you the center of rotation. Sometimes it's just nice to have a visual cue of what you're rotating, or of the spot you're rotating around, just because just to make it a little easier to know how your geometry is going to be rotating. Just some smaller miscellaneous things with the user interface. One of the things was the equation editor used to be static. You couldn't resize it at all. Now at least you can resize it up and down. We also changed the order of the functions just to make more sense. We tried to group like things together. We added a function called lfic, which returns the planar element corner thicknesses. This is sort of a little underrated one, but just more of a quality of life item. When you did view options, if you used the color palette and you selected a color, when you came out, you were always still in the same color mode you were in. What we do now is we just automatically change it. We change you to view color. Otherwise, when you hit OK or apply, nothing would actually happen on the screen typically because you were still looking at the other color. So it's just something, just to make your life a little easier. Also, we added you couldn't actually use select visible, the select visible icon that we had when you were with solids on the screen. We made that work. Now just realize that it's only going to be selecting parasolid solids, not any Femap volumes if you happen to still have those in your model. Also just added some nice grouping commands. You can now put these on toolbars if you like. And then one of the other nice things is once it's on a toolbar, then I just hope everybody knows that then you can you can set the category for a keyboard shortcut just to that toolbar, and then you can actually pick those commands and you can assign shortcut keys, hotkeys to those icons. So that's just something else we did. When we're talking about beam properties in Nastran, what we added was we added this right zeros at end B, off equals blank, and by default, it's going. This option is going to be turned off. So what does this do? If you have a tapered beam in Nastran, if you have end A value specified but you don't have end B, then end B automatically gets end A when those fields are blank. For whatever reason, perhaps somebody might want an actual 0 to be placed in that field instead. That's why we have this option. You just turn this on, and then it'll write it, and then it'll write a 0 instead of a blank. So then this is just showing you in the preview pane, just basically the same property, one with this option turned on, which is on the bottom, and one with it turned off, which is default, which is the one on the top. We added the ability to set the output coordinate system at any time via tools parameters. And while we added monitor points and matrix input, DMIGs, for 2020.2, for 2020.1, we actually did not include the ability to set the color, next ID, or increment via the tools parameters command. So we added that in for 2020.2. Big one that people always asked for was the ability to select multiple solids when using mass properties, solid properties. And what this can do is this can compute an overall assembly properties for all your selected solids. Or if you want, you can have it just compute them one at a time for each selected solid, but at least at least you can pick them all at once, and you can just have it crank through any number that you have. There's also now a send to clipboard option here, which will automatically send what we're sending to the messages window, also to the clipboard in text, or rich text and HTML format. Now, the other thing we did was, as soon as you got done using this command, it used to ask you a bunch of questions. Now you basically just choose if you want to create a node at the center of gravity, create a representative mass element at that location, and whether you want to link it to an existing mesh. And when you do multi-element connection, it'll allow you to pick the nodes you want to go to. If you use the single element connection option, the one that's specified there, then what it'll actually do is it'll actually bring up the dialog box from the mesh connect closest link command, and then you'll be able to choose whatever you might want to hook your mass element into the rest of your model. We also just added a send to clipboard option to the tools mass properties mesh properties command. Again, sends it in text, rich text, and HTML format. Another thing that we did here was we actually never included solid laminate elements in the mesh properties before. Now they're included as of 2020.2. Added support for follower force and follower moment. Follower moment. So essentially what you can do is you can choose either to be 2 nodes that specify a vector, or 4 points that specify a plane, and then the follower force or moment will act normal to that plane. And you can specify these both for nodes or on any type of geometry. Just something to notice there is that this is Nastran only. This was actually done for 2020.1, and I just realized it was never in any of our other presentations. But we added the ability to, we added coordinate systems to the other entities to include section. So when it's enabled, all the coordinate systems referenced by all the entities being duplicated will always be duplicated just completely all the time. If you have it turned off, only the coordinate systems that are absolutely needed to maintain the intent will be duplicated. So you might have noticed with these new copy commands that you were ending up with, you could end up with a lot of new coordinate systems where maybe you just didn't need them, and this was certainly a difference in functionality between the old way that we copied and the new way. So this option kind of gets you back to the ability with some of the older commands that we had. We also just added an assign active color and assign active coordinate system options for your newly duplicated entities. And then for 2020.2, what we added was just the ability to duplicate materials and layups. So essentially, we weren't duplicating the materials that were on layups of properties before, and now we're doing that. So that's specifically for laminate and solid laminate properties. Okay. Meshing. One thing that we've added relatively recently in the feature removal was the blends. So I think it was 2019.1 or 2020.1, we did a big upgrade of the way that we did blend removal. So we would try to remove them all at once. Then we actually kind of went through finding chains of blends one at a time, and then trying to remove them. And then we actually ran through that step again, just because it's sort of an order of operations sometimes with blend removal. So we would just kind of run through. So we basically added a lot more robustness to when we were getting rid of blends. So the one thing that was sort of missing is that you really had no idea what Femap was going to try to remove, and if you didn't set a limit size, this command just sort of would get rid of whatever it wanted. Okay, so what ends up happening is it's going to highlight all the blends in your model. So what you can then use is you can use the standard selection dialog box to then now add or remove blends from your model. Okay, so you can basically just pick and choose which ones you want it to try to remove, and then it's just going to, once you have the selection done, you basically just say okay, and then it just removes them all in a single sweep. Another thing that we have here is we have the meshing toolbox. We have geometry. In the geometry editing tool, we have the extend operation. So before we didn't have the geometry type option here. Everything was just curve on surface. So essentially what we did was we added a surface replace face option here. So this just kind of allows you to raise or extract surfaces to main solids and remove features. So in this case, these are some stubborn blends that couldn't be removed for whatever reason, because Femap doesn't actually think they're blends. So what you could do is you could pick a surface to extend to or a destination surface. You could pick which fillets or blends that you wanted to remove. And then what it's actually going to do is it's basically just going to take those surfaces and it just replaces them with your destination surface. So it's just another way to remove blends in some cases. Another thing that you could do here is you could also just, let's just say you have solids that are slightly different thickness. What you could do is you could just pick the destination surface, then pick a surface on the other solid, and it's just going to extend that out to here. Okay, so I'm going to try to go back into Femap. Hopefully it's going to cooperate with me now. Oh, there we go. Okay, so I'm going to go to extend, and I'm going to choose, I'm going to choose this surface replace face option. I'm going to come in here, I'm going to pick my surface. Okay, so that's the one to extend to. And now what I'm going to do is I'm going to come in here and I can just pick which ones I want to get rid of. And in this case, I'm just using it for feature removal. But I can also change the destination face here. So these are actually sticking out. And I'm just going to, now I'm just able to come in here and get rid of these as well. And kind of the final one that I just wanted to show you again is this. And now I could just come in here, get rid of and get rid of these as well. Okay. And so you can see it's able to get rid of that. If I just did them all at the same time, it would be better. Okay. All right. Well, here, let's just go back to the presentation. Okay. The mesh editing commands, essentially these commands, interactive split, element refine, and edge split, were added at various times in Femap. I mean, some were added all the way back probably in version 10, whereas like element refine was probably, I think, added in 11.2 or 11.3. Now the thing is that the way that these commands handled these items, updating nodal constraints and nodal permanent constraints, updating loads, updating regions, updating tapered beam shapes, beam offsets, plate thickness, material direction, etc., groups, any geometric associativity. All these commands were completely different from one another because, again, they were all coded sort of at different times. So basically what we did in 2020.2 was we just made all of these commands work the same when it comes to these items down at the bottom. Improved mesh sizing, that was, I mentioned that earlier. And something else that we did, when you're making combined curves, basically this is typically done to improve the mesh quality. What we allow you to do is we only allow you to combine curves that are the same. So if they're free edges, yeah, we'll allow you to combine them. If they're both manifold edges, we'll allow you to combine them. Both non-manifold, wire body, because what we found was combining these when they weren't the same really ended up typically making a worse mesh for you than a better one. So now we just restrict this, and we could not find a good reason not to do the restriction. But if somebody out there has one, just let ATA know and they'll pass it on to us, and we'll go from there. Post-processing. So we have a list output results to Excel command. So this works very similar to the list output results to data table command. So it automatically opens Excel and transfers the variety of results very quickly. So the dialog box looks almost identical to results to data table. The one difference is that there's an option there for formatting instead of summary table option. But so you have row column control. You can do the ultimate column order if you like. If you like, you can transform your results. So you can either use the transformations from the active view or set some custom transformations. And one of the nice parts about this is you then select your output sets and your output vectors. And what it can do is it can actually transfer nodal and elemental results at the same time. So what do you end up getting? You end up getting a nicely formatted spreadsheet that automatically has column filters, frozen row headings, frozen ID columns as well, and nodal and elemental results organized by different sheets. I'm just going to go over into Femap here for a second. I'm just going to show you this. So we're just going to do list output results to Excel. I'm going to just say OK here. Just going to pick all my output vectors. And then I'm just going to pick a subset of nodes and a subset of elements. I'm just going to say OK. And what this is going to do is this is just going to automatically open Excel. And OK. So then here's our nodal data. So as you can see, as I go up and down, the column headers stay at the top and the IDs always stay to the left. If I come over here to elements, it's going to kind of cruise down here. Oh, okay. I must have gotten some. Oh, yeah. These are, I included beam output, which I probably shouldn't have done because I didn't pick any beams. But then you can see, so that's how that works. Okay. For anybody doing aeroelasticity, static aeroelasticity, solution 144, we had support for the aero pressures, aero coefficients, and aero forces. Remember, these are only in the FO6 file. So if you've been reading the OP2 and you're not going, these output quantities are not going to be read in to Femap from there because they don't exist in the OP2. For solution 402, we actually added the support for the shell THK, the shell thickness output request. So as you're doing solution 402, you know, like a model like this, as it deforms, it gets thinner. This was actually something we added specifically to help support ATA, their solution 401 and 402 training class that they made for Simcenter Nastran. Same thing with plastic strain. We added support for that as well for solution 401 and 402. Another thing that we did was we added support for progressive ply failure, so PF results from solution 401 and 402. So these are damage status, damage values, damage energy, and crack density. So that's just some examples. Just going to go over into Femap for a second again. Just kind of wanted to show you the mat damage here. This is these are cohesive elements. So this is actually a bunch of laminate solid elements with just some cohesive elements in between. So I just turn off the laminate solids. And then I'm just, you know, so I can actually see this is just a solid cohesive damage value results. So those are now in Femap as well. Okay. Something we had an API for a long time was to compute the averaged mid-stresses and strains. So we just basically decided to add this as an option. So you can just turn this on as a preference. So once you've turned it on as a preference, what you end up getting is you get the simple average of top and bottom results. We're not doing any other interpolation. So if you're not at, you know, plus minus half Z thickness, it doesn't matter. We're just taking whatever top and bottom results that Nastran or whatever solver's given us, and we're just doing an average. So it includes the computation of invariance based on the average mid values. You can do it for both attached and imported results. What you'll get is vectors in the 8,000 range for plate elements, or, you know, shell elements in general. So that's just another nice feature. Stress linearization, again, something we had an API for. We actually had an entire Visual Basic one that you could install, and it would show up as an add-in and all this other stuff. So stress linearization is based on ASME boiler and pressure vessel code. What does it do? It calculates a linearized membrane, linearized bending and peak stresses along a stress classification line. And essentially, the new interface in Femap looks like this. So it's very, very important if you're going to use the stress linearization capabilities that you are familiar with the code itself, with the ASME code, because choice of the stress classification line is absolutely critical. So if you don't use it in the way that it's prescribed in the code, the results you get probably aren't going to be all that useful to you. So how does it work in Femap? You choose an output set. You choose whether you want linear or nonlinear results to use as a stress tensor. You choose an element type. You choose a criteria. So whether you want to do von Mises stress or Tresca. You then pick the two nodes for the SCL, and then you hit the calculate button, and then you get this graph. And this is the way typically the results from this type of post-processing are delivered to people. So, just graphically. So there's also a copy to clipboard option. Just know that there's also the ability to do full component bending. That's just an option. That's not what the code prescribes or tells you to do, but if for some reason you wanted to include that, that's certainly an option that we have as well. And the Tresca in this case is just simply, it's calculated by 2 times the maximum shear. So that's how we get the Tresca stress criterion. And again, it works for a lot of different, a bunch of different element types. I'm just going to show it to you here on a axisymmetric model. So we're going to do list output. I'm sorry, we're going to do view, advanced post, stress linearization. So here's the dialog box that comes up. You just pick an output set, and then you just pick 2 nodes, and then you say calculate. And we're always going to show you the SCL that you've chosen, the stress classification line, as a red value there, just so you can see that, and just so you can kind of see how it can change. You just pick 2 new nodes, and then you click that, and then you can do a copy to clipboard here. And if you want a couple more copy options, there's just a couple in here, because what this actually is, it's just a subset of our charting pane that's embedded within this dialog box. Okay. Solver support, something people have been asking for a long time, is support for the Gen L, the Nastran general element. So we added support for that. Now, most of the time, these are being generated by a secondary process, which just creates the Gen L, and then you would typically just include these with your, larger type assembly models. So a lot of these, a lot of times you're simply just going to be reading these in, but it is nice to be able to visualize how they're connected. And if you wanted to look at the matrix components for that matrix element, we import all those values. You can take a look at them. If you wanted to define them or change them for some reason, you can certainly do that from within Femap as well. Follower forces, again, these were mostly for Nastran. I mean, these were specifically added for Nastran. Now, where do you use these? Well, if you've chosen 2 nodes or points, you'll get a force 1 or a moment 1. If you've chosen 4 nodes or points, you'll get a force 2 or a moment 2. And these are typically used with solution 106, 401, and 402. We added the ability to specify true stress versus strain and true stress versus plastic strain. Again, this was support for solution 402, so it's just a new function type that you pick. Also, the Z offset, so shell element thickness, can now be considered for solution 402 when in contact. And as I mentioned, we support the progressive ply failure. Well, the way that we really did this was we recognize if there's one of these in there, which is a Simcenter Nastran unidirectional ply failure or enhanced unidirectional ply failure, which actually makes what a MAT damage, like I always call it a MAT damage, but just simply a MAT DMG entry in Nastran. So essentially, this is one of our other types of material. It has to be, so it actually hooks back to a regular material. So you simply just put the material ID in this field, in this first field here, and then you just specify the rest of your values. Oh, yes. Also, we added a third new function type, which is shear damage versus thermodynamic force. The only place in Femap it's used is to set this damage evolution value right here. For ANSYS, we added a bunch of options. So what these allow you to do is just skip portions of the model. So you can skip you can have, when it writes out, you can have it skip coordinate systems, nodes, materials, properties, and or skip elements. You can have it, you can have it skip groups. So it allows the user to skip writing E cell and N cell and CM entries during export if you like. And then skip miscellaneous. This just allows you to skip like view settings, preprocessor commands, solution settings, and other commands such as solve and finish. This essentially, when you use the skip misc here, essentially what it's doing is it's almost like writing you out a bulk data file in Nastran terms, but you're doing it with ANSYS. The other thing that we did, ANSYS started compressing the results. So the results files, by default, I believe starting with ANSYS 19.3, were coming out at, compressed. So we actually now have an option whether you want to have the compression or not. And but we realized that people probably would like the results file to be compressed whenever possible. So we added support for reading the compressed results file, and currently we support what's called what they basically call version 1 compression. Also added manual control sections to all of those, basically all the dialog boxes for the ANSYS that are in the analysis set manager. Did very similar thing for Dyna, with the ability to skip different element types. If you skip groups, we don't write we skip writing the star set. And in this case, you can also skip functions, which won't write star defined curve entries. And if you use the skip misc here, so it skips comments, star keywords, star title, and just these items that are listed here. There's also now an LS-DYNA analysis monitor. So if you have Femap automatically set to launch LS-DYNA, you now get an analysis monitor like we currently have for Nastran or end-to-end ANSYS. For Abacus, we added support to preserve load BC sets. So when this is enabled, when you're importing loads and boundary conditions, which reference a set, what that'll actually do inside of Femap is create load definition or a constraint definition. And sort of on the flip side of that, if you use the write all groups as sets option when you're exporting an Abacus model, anything that is a load definition or a constraint definition in Femap will be written out with a set command instead. So it's just a nice way to have your Abacus models, your Abacus input files arranged. Some miscellaneous stuff, just the API programming pane, we now have an auto completion favorites. So when you use a method or you use an item that comes up in IntelliSense, the next time you go to use it, that's going to move to the top and there's going to be a little asterisk in front of it. So you don't have to go down the entire list of options in the IntelliSense. Just remember that the favorites persist for a session, but not across sessions. It's just something to know. And also symbol highlighting. So when you click on a parameter method or other symbol in a script, the user interface will now highlight that item throughout the script. It just makes it a little bit easier to find. There's also an additional scroll bar, which appears that it kind of allows you to move up and down the window very quickly to find instances of a particular item. Also, something we should have done a while ago, the watch window is now the default tab displayed when debugging in the API programming pane. Something for more serious API developers is that you can now control multiple Femap sessions via the API. This includes Excel VBA developers, so you can control multiple sessions simultaneously. It's only forward compatible, so this only works 2020.2 and above. And essentially, we just have these two new options, these two new calls, app running application info and app running application. And you can now create sort of a little handler that can allow you to be able to work with multiple Femaps at once. Also, for whatever reason, we never gave people API support for the file merge tool. That's been added. It basically works exactly like the merge tool, just programmatically. One thing you can do with it that you can't do via the user interface is you can actually have it make merged patterns. So that can be very helpful. We also gave access to the stress linearization tools. So the stress linearization functionality is also now in the API. And it just allows you to essentially do stress linearization. Let's say you wanted to make 17 of those stress classification lines, and you just needed the results from each one of them. But you didn't actually need to physically see them because you actually kind of know where they're going to be. You can just use the API to, do that in a loop. So just a few things about MP1 here, about 2020.2 MP1. The model load expand command, significant improvement in performance when expanding loads, geometric loads on large models, especially surface-based loads of models meshed with solid elements. And what's nice about this is it also improves commands that expand loads like tools check some forces, anything, model analysis, especially when you're pressing the preview button, because when you do that, all the loads always have to be expanded so they can actually be written out to the analysis input file. So just by fixing that command, it actually helped a number of commands. Another thing that we did was we found out tools check coincident points was very slow. It used kind of old it used old technology that we had in Femap. It's essentially the original technology we had for finding coincident nodes, but we changed that probably at least 15 years ago. But we just actually never brought it over to the points. So essentially, we're just using that same technology now. Anyways, so it went from a model that contained 200,000 points and 320,000 curves that formerly took over 16 minutes to merge, now takes under 4 seconds. So a 240 times speed improvement. And that's one of those ones where we just didn't know it was slow. And then we were actually trying to help a customer out with something, noticed it, and it was fixed in an afternoon. So a 240 times speed improvement in an afternoon. So sometimes what I'm trying to say there is sometimes we don't know something is slow. So if you think something is just overly slow, like why is this taking so long? We implore you, just let ATA know, and hopefully they'll pass it on to us, and we can see if we can't make a big speed improvement. Also added the ability to import SolidWorks files with an SW argument if you're using the command line prompt. Significant improvement when converting between nodal and element results when you're looking at a contour plot. This also had the added benefit of helping out the model output process convert command. So again, just another huge improvement. Even though it was brand new, we actually found a much better algorithm to determine which elements were along the stress classification line in stress linearization. And then we added just some new API commands there. Something just to know about 2020.2, and if you need to know more about this, it's all in Software Field Bulletin, the one that's listed here. Essentially, if you're using the external Femap neutral file calculator, neutral file converters, you could have an issue. So anything so in your model, well, it only affected a small subset of models. So if your model had aeroelastic control surfaces in it, they wouldn't be transferred. If it had API sets that were saved, that's more of an API thing more than anything. But the big one that, and this is how we sort of found this problem, was that if you did have an ID larger than 99,999,999, those entities would not be imported by the external converter. Now, this was all corrected in version 2020.2 MP1. And the simple workaround, if you're bringing something from 2020.1 to 2020.2, is if you manually use the file export Femap neutral command, and just to write a 2020.1 neutral file and then imported that into 2020.2, there was no loss or entities of entities or references. So that's just something to keep in mind. Okay, so that's it. So let's go to the Q&A.
Awesome, thank you, Andy. That was really great. I know I learned a lot. I have a couple questions in the chat so far. I'd encourage anyone else out there with remaining questions to enter those questions in the chat, or when I finish going through these, then you can also unmute yourself if you want to just ask over the phone. But I guess kind of to start things off is lots of really impressive performance improvements, like up to 240 times faster, which is just like crazy and awesome, especially as models continue to get bigger and bigger. But do you have any feeling for if that's going to be like representative of future releases? Like, is this kind of what we can expect going forward?
Well, so version 12 was a very feature-rich release, and then as was 2019 and the combination of 2019.1 and 2020.1. We just felt it was a good time to just focus on performance and just make, I used it a couple times, the word quality of life improvements for users. If you don't keep on top of these things, they can really impact people's productivity. So just fixing some of these performance lags just seemed like a good idea at the time. I think especially if you're using larger models, you're just going to see a almost kind of night and day differences. Now, is every release going to be like this? No. Certainly we're going to do performance work in some releases, but most of our releases will probably go back to will be feature based releases more than kind of focus on performance like this one was.
Okay, cool. And I guess sort of along those same lines of productivity, we've had a lot of users that have been very thankful for we call them the COVID licenses that have been made available for dongle or node locked users, and essentially that sort of lets people get around the restriction of using those dongle or node locked licenses over remote desktop or something like that. Do you have any feel for either if those licenses will continue to be made available on a month-by-month basis, or if there's any talk of just kind of removing that remote desktop limitation?
Well, I can certainly say that we are going to, the one for August has already been placed. It's already available on GTech or Support Center. We're probably going to continue it, for a long time now. Now the whole thing is that there's actually no way, I believe, to override that issue when you're using a dongle. Okay, so so it's now, and the other thing is that perhaps if you did want to use it like that, perhaps what we could do is make the way it works is there's a feature inside of FlexLM, TS_OK. Perhaps we could just make that an option that might be available for purchase. Not a lot, but that might allow someone to work like that moving forward. We actually really haven't decided on that one yet. I mean, we really just got that COVID license out kind of as fast as we could just to try to help folks out.
Sure. Yeah, and we've had feedback from a couple of our users that are really thankful for that. So thank you. I see you playing with the blend removal. Do you want to talk to this now that you've gotten this running?
Yeah. I'm still a little confused as to what's going on, but I'll just show it. Sure. So this is what I was trying to show you guys earlier. Is essentially when you pick here, it's going to preview. So now these are probably not blends we wanted to include. So I'm kind of glad it's going to try to not get rid of those automatically. So what I can do is I can come over here and I can turn on the limit size, and I can just do 0.25. Come here. Okay, so now I'm getting a preview of my blends. I probably don't want to remove these again, so I'm just going to get rid of them, and then I can just come around and just pick some of these. I can always highlight again, see what I have chosen, just pick a few more that didn't get picked up by the automatic blend locator, which is actually really just it's just code inside Parasolid. So I'm just going to say okay, and then once I kind of have it, then I can just say okay, and then it's just going to it's just going to come in here and it's just going to remove all these blends at once. So just, you know, some nice functionality to allow you to pick and choose kind of what you want. Okay.
Awesome. I think this is going to be the last call for questions. I don't see any others in the chat. So please feel free to reach out either now with those questions, or if you come up with a question, you know, this afternoon or next week or anything, feel free to reach out to ATA. But if there are no other questions, thank you, Andy, so much for joining us today. Really great presentation, and I hope everyone has a great afternoon.
Thank you, Jonathan. Thank you, everyone.
Great. Thanks, guys.